Assalamualaikum warahmatullahi wabarakatuh, and a very good mornings to all. Thanks to all for joining our event today. By the way, my name is Shazli, and I will be your host for today's session. So how are you guys doing today? Hopefully you are all doing well. As you all know, we are now in recovery phase of MCO, and hopefully we all can fight this pandemic together by keeping ourselves hygiene and keeping our social distance always. I would like to welcome everyone to the MTSFB public engagement session for draft technical codes to address 5G requirements. I would like to welcome our Malaysian Technical Standards Forum MTSFB Board of Directors, Malaysian Communications and Multimedia Commission representatives, all MTSFB registered members, Puan Zaliha Abu Bakar, our General Manager, MTSFB office bearers, and everyone who participating in this live event. All right, ladies and gentlemen, we are sad to inform that we had just lost our committed chairman of board, yang berbahagia Datuk Ismail Osman, on 28th of May 2020. And for Muslim, let's recite Al-Fatiha, and for non-Muslim, you may remain silent. It's a great loss to us and to the communication and multimedia industry with the loss of yang berbahagia, the late Datuk Ismail Osman, our chairman of board. All right, ladies and gentlemen, live right now at our Facebook, we have around 83 or already 90 participants who joined us. It's an overwhelm to welcome all of you to our MTSFB public engagement session. Really thank you for joining us. We really hope that you could please like, comment, and share this live event as well, so that more can be joining us. Ladies and gentlemen, 5G is coming to Malaysia, or I could say 5G will be commercialized in Malaysia soon. Thus, our draft technical codes or our technical codes will play a very important role to make sure that 5G requirements is addressed, and so that the 5G is working in terms of interoperability and reliability in Malaysia. Basically, this public engagement session is organized to enhance the content of the 5G technical codes developed by International Mobile Telecommunications and Future Network Working Group, or we call it IFN Working Group, and Security, Trust and Privacy Working Group, or STP Working Group. It is also served as a platform for the public and the relevant stakeholders to have direct communications, feedbacks and comments with the experts. All right, before we start with the presentation by our presenters for today, allow me to state a few ground rules. Number one, please leave your questions at the chat box. Our subject matter experts will answer to those questions during Q&A session. All right, please don't forget to state your name and your organization name for our record. And number two, at the end of the session, we really love to get your comment and feedbacks on this event. All right, I would like to inform also to all of you that our public comment exercise for these draft technical codes is still ongoing, and comment form available online in MTSFB website. We also put the comment form at the in the fifth generation system. All right. He is Mr. Anwar Faiz Osman. He is the chairman of International Mobile Telecommunication IMT 2020 Sub-Working Group. And he is currently working with Rod and Swart, Malaysia Sdn Bhd. All right. How are you, Mr. Anwar?
I'm fine, thank you. Mr.
Yeah, okay.
Ready, thank you.
Great, Mr. Anwar. Okay, so without further ado, I'll pass to you to present on the draft technical code for technical specification for IMT 2020 fifth generation system. Please welcome.
All right, thank you for the moderator for the introduction. Assalamualaikum and good morning to everyone. My name is Anwar, the chairman of the technical code draft for the IMT 2020 fifth generation system or 5G. And today I will present on the details of our proposal in the technical code document. Can you see my screen, right? Okay, next, I would like to go to the outline of this presentation. The first one that we're going to talk about is the background for this document and why do we need it. The second is the objective of the document. And the third agenda will be the scope of the document. Then followed by the main item that I would like to highlight from the content of the document. The fifth agenda will be the progress of the document so far. The sixth agenda will be who are the beneficiaries of this technical code, followed by the conclusion, and lastly the acknowledgement to the team members. Okay, let's look at the first agenda, which is the background of this technical code. So first of all, what is 5G NR? Okay, NR here means new radio, the term that we use for 5G. So let's look back into the 1980s. We have the 1G or the first wireless communication, which is designed only for voice communication with a speed of 2.4 kilobit per second only. So this is basically for analog voice transmission. And then when we go for 1G to 2G, we are start to transition from analog to digital. This technology, 2G, is designed for voice and data. And so we have been introduced to the messaging services such as SMS and MMS. So we have a better coverage and better capacity as compared to the previous technology. And we first have the global standardized for the technology, which is GSM or CDMA. Next, we go to the year 2000. We start to have the 3G technology. So this technology is designed for voice communication, data, and also video, multimedia text, and internet. So we start to have a mobile data services, and the public and the users can start to surf the internet using the mobile handset. And we first have the first broadband services in the mobile service, and the speed is about 2000 kilobit per second. And in the year 2010, we start to have the 4G technology. So this technology is designed apart from the voice, data, and video. We also start to have the application, and we start to have gaming, and also for mass computing usage using the mobile device. And the protocol is based on IP, and it's start to have high-speed internet, which go up to 100 megabit per second. So what is the difference between 5G? So 5G, we will start to have a very high speed and low latency technology, and we start to have the use cases, different use cases that can be used with this technology, which is either the high speed internet or ultra reliable low latency, and also for the massive machine. So the potential to have some services like the mobile or remote surgery, for example, smart cities, smart factories, and so on. And the speed here, we're talking an average of transmission by 20 gigabit per second, and latency as 1 millisecond, which is can be used as the use case that I mentioned before. So what are the main pillars of 5G as compared to the previous technology? So we have, first is the new spectrum that will be using in 5G. And apart from the below 10 gigahertz or below 6 gigahertz frequency that have been used in the previous technology, we will be looking at the millimeter wave frequencies, such as in the 28 or up to 40 gigahertz. And we start to have this, the second pillar will be the multi-connectivity. So we have a few options on how the 5G base station will be set up, either using a 5G core or 4G core, and the combination of the radio side to have this combination with 4G and 5G, or just 5G only. And in the antenna side, we will have the massive MIMO or beam forming capability, and the handset itself is expected to have beam steering capability, which can improve the coverage of the receiving signal, as well as better capacity. And lastly, we have the network flexibility in terms of the application of using the network bandwidth to have multiple applications to share the same bandwidth. So here we're going to have these different sub-carrier spacing as compared to the previous technology, which is fixed. So it's more flexible and more complicated in 5G. The reference document that we are using is basically from ITU and as well as from the 3GPP document. So these are the timeline of the 3GPP standardization document. We have release 15, which have been frozen in December last year, right? And the test specification for the release 15 had been completed. So recently in June, we have this release 16 just frozen. So we have additional specification, especially on the massive machine or mass IoT that we can set for the 5G standard. And of course, going forward, we have the release 17, which will cover mostly on some specific use cases, and it's expected to be released in release 17. So these are the timeline for the international standard document that we use as a reference for the technical code. So next, I would like to talk the second agenda, which is objective of the document. So why do we need this document? So basically, when we want to have a 5G system in Malaysia, right, we need to have a document that state the minimum requirement or the initial state of the features to be introduced in this service. So basically, we're using the TPP Release 15 as the initial state and the standard requirement for 5G system. So this document will be a guideline and to ensure the 5G system able to provide the minimum required service performance to the consumer. So these are the reason why we want to have this document, as well as to give the operator a checklist of requirement for them to have the 5G system to be deployed in the network. Now let's talk about the scope of document. So the title of this document is Technical Specification for IMT 2020 of Fifth Generation System. And this technical code specifies the minimum requirement for 5G system for terrestrial, mobile radio and core network, excluding the 5G user equipment. So it defines the specification for the radio side and the core side, but it's not covered the 5G handset or the CPE. Now we come to the fourth item, which is the main item of the document that we would like to highlight to the public. The first one is the general requirement for 5G. So basically, it is based on this the three use cases that we want to provide from the 5G service. The first is the enhanced mobile broadband, right? Here we have defined that the user experience data rates vary from 1 gigabit per second for downlink and 500 megabit per second for uplink for indoor environment, and for the rural will be 50 megabit per second for downlink and 25 megabit per second for uplink. And the minimum requirement for user plane latency is defined by ITUR M2410 is 4 milliseconds. This is the first use case of the 5G that we highlighted in the document. The second would be the massive machine or massive IoT. And for this, we have stated that the capacity target can be as high as 15 terabit per second per kilometer squared, with about 250,000 users per kilometer squared for indoor environment, and as high as 500 megabit per second per kilometer squared with 100 users for rural environment. And lastly, for the ultra reliable and low latency communication, the specification as defined in this document will be end-to-end latency target as low as 1 to 10 milliseconds for automotive and automation interaction. The minimum requirement for user plane latency as defined by the ITU is 1 millisecond. So this is the general requirement for 5G will be stated in the document. And in terms of the architecture, we have selected the three types of architecture. The first one will be the 5G non-standalone option using the 5G RAN combination with the 4G RAN. So the control plane will be on the 4G radio, but the data will be mainly coming from the 5G for the capacity. But the core for this architecture will be coming from the 4G core. So this is the first option. The second option, it will be the 5G standalone configuration, where we have solely 5G radio connected to a 5G core. And the last one will be the non-standalone deployment using the combination or the various combination of radios from 4G and 5G, but connected to a 5G core. So these are the three options of 5G network architecture that we have defined in the document. And for the 5G technologies, okay, we have segregate the tasks that need to be performed from the 5G radio side and as well as the 5G core. So for the 5G radio, it's mostly on the intercell radio resource management, resource block control, connection mobility control, radio admission control, and measurement configuration, as well as the dynamic resource allocation. So these are the tasks that will be highlighted or defined by the radio side for the 5G technologies. For the 5G core, will be the network attached storage security, either state mobility handling, PDU handling, UEIP address allocation, and PDU session control. Okay. Next. So there will be no change regarding base station function, and the mobility anchoring and IP address allocation will be maintained. And for the EPS barrier control, from 4G we developed to the PDU session control. For the 5G quality of service, the 5G network shall have a standardized set of quality of service characteristics, which are based on the QoS or quality of service class identifier or QCI. Then this QCI will be aggregated from the multiple session of service data flow or SDF, and the QCI shall be used as a reference to note specific parameters that control packet forward treatment. For example, to do the schedule waiting or admission threshold, queuing in the management threshold, and also in link layer protocol. And that have been pre-configured by the operator controlling the network node. So for the 5G quality of service flow, right, we have the QCI table defined in the document as shown in the slide, and we have stated the flow of the quality of service from the data packets coming from the application, and then we apply the network need to apply the rules for the QoS, such as map the uplink packet to the QoS flows and apply the marking. And from the flow, the all packet from the UE will go to the radio side and the PDU session and the UPF. So these are the description or summary of the quality of service flow as defined by the document. Now let's talk about the 5G NR spectrum that is available or being defined to be used for this technology. So in terms of 5G, there will be two categories of frequencies. The first one is called FR1 or the sub-6 gigahertz frequency. So this frequency started from about 700 megahertz up to 6 gigahertz, or based on release 16 will go up to 7.125 gigahertz. And the next frequency range will be the FR2 or the millimeter wave, and this is basically the 28 to 40 gigahertz transmission. So the operator who globally who want to deploy for 5G will be providing the service based on this list of frequency range as defined by 3GPP. Now we would like to go to present the progress of this document. So we have started to register this document proposal in February, and we had about 8 meetings between the members of this technical code, and we have submit this document for the public engagement circulation. And today, 10th of June, we have this public engagement day. Please take note, the public engagement runs from 18 May to 17 June. So for the public who wants to give the comment, this is the time frame to be done. And we plan to submit the final document to MCMC on the 16th July for approval. So this on the right side is the table of the date and the deliverables for the deliberation of this document. Now let's talk about who are the beneficiaries of this technical code. So the first beneficiary of this technical code will be the telco service provider or the operators, because this document can be the guideline for them to define or what is the minimum requirement when they want to deploy the 5G service. And the second is to provide the assurance to the public that the 5G service that they are receiving meet the standard minimum requirement as defined by the global standard. And thirdly, right, is to ensure the consumer is provided with the required quality of service from the 5G service provider. And lastly, to the beneficiary will be the network equipment provider for them to know what is the correct architecture of the 5G system to be installed in Malaysia environment. So these are the four main beneficiaries from this document. I have now come to the conclusion. So based on the points and items that we highlighted from the document, it is crucial for us to have a standard document to specify the minimum requirement for 5G system, which include the 5G base station and the 5G core. And as such, we from the Technical Code Committee recommend that this document to be approved and to be used by all the relevant parties. Lastly, I would like to acknowledge the members who have contributed for this document. So these are the company representation that provided the input and suggestion and comment for this document, especially the NTFB, the operators, MCMC, as well as other universities and research company that provide the input. So I would like to thank them for their support. All right, thank you very much. That's the end of my presentation. I would like to hand over back to the moderator. Thank you.
All right. Thank you very much, Mr. Anwar, for the great presentation. Ladies and gentlemen, we are really sorry for the disappearing voices sometime that you may face. All right, maybe the connection is not stable. Anyway, please leave your questions at the chat box. Our subject matter experts will answer to those questions during Q&A session. All right, please don't forget to state your name and your organization for our record. All right, I think we will proceed with the next agenda on the presentation for the draft technical code titled Prediction and Measurements of EMF Exposure from Base Station. The presenter is IR Dr. Nurul Huda Abdul Rahman. She is the draft lead for the electromagnetic field subworking group, and she is currently working at UITM. How are you, Doctor? Dr. Huda, are you there? Maybe you want to unmute. You need to unmute your mic.
Okay, sorry. Hi, Shaz. I'm good, thank you.
Okay, without further ado, I pass to you, Dr. Huda, to present on the draft technical code on prediction and measurement of EMF exposure from base station.
Right.
Please welcome.
Okay. Thank you, Mr. Shaz, the moderator of this session. So my name is Nurul Huda Abdul Rahman. I'm the secretary of the EMF subworking group and also the draft lead of these technical codes. So before I begin, together with me today, we also have Prof. Tariq, the advisor of our subworking group. So thank you, Prof, for joining us. And then this is the content of my presentation. So basically, it has the introduction, standards, and all the relevant chapters that we have already included inside the technical codes. And our subworking group is actually under the IFN working group. So our subworking group is chaired by Prof. Yamada from UTM. And then the vice chair is Mr. Amir from DG. and I'm the secretary, and we also have members from many sectors like telcos, vendors, people from ministries, and we also have government agencies and so on. So we have a lot of experts that contributed to the development of the technical codes. And then this is the purpose of the technical codes. So as you can see, the main purpose is to address the EMF evaluation method for radio communication base station that radiates in the frequency range of 0.1 megahertz to 300 gigahertz. So as you can see here, this frequency range covers a lot of mobile technologies. It's not just 5G, it also covers the previous mobile technologies. So this document is important because it is to serve as a reference document for industry and regulator like MCMC, especially in determining the compliance. Also, it can be used by the public to identify the method to evaluate the EMF exposure, especially when it relates to safety and health. So specifically, this document or technical code provides prediction and measurement method. So this is to determine the field strength and power density, which is two parameters that is very important in determining the EMF exposure. So the scope that we cover is for IMT base station, which is mobile technology base station. So this is the purpose of evaluating EMF exposure. So I just want to highlight that we're not covering EMF due to SAR, due to specific absorption rate by mobile phone. We only cover the EMF exposure due to base station. And then these are some of the interested parties that may be beneficial by this technical code. So we have NSP, NFP, and also maybe MCMC can get benefits from these technical codes in terms of compliance. And then Malaysian Nuclear Agency, because they have been continuously performing measurement for EMF. And then vendors, also local councils, and also the public. So this is the timeline of the revision works of our technical code. As you can see here, we have started our work since early 2020. Actually, we have started in 2019, but we have been changing our scopes, and we have been revising our technical codes many times. And finally, we have came up with the draft, and currently the draft is undergoing public comment until 18th of June. So it's week 3 now. And we will also like to receive feedbacks from the public and also the industry regarding the content of our technical codes. So please submit your comments. And then this is the content of our technical code. I just want to highlight on 3 important things that we emphasize on these technical codes. The first one is the calculation of safety zone. So that is defined in clause 7, which is the calculation of exclusion zone or safety zone. This is based on the IGNIP exposure limit specified in clause 5. And then we also, item number 2 that we want to highlight is the simulation method. So that is explained in clause 8. Because for some cases, we cannot do calculation of safety zone. So we have to do simulation of in order to predict the safety zone. So that is defined in chapter 8. And after that, we have to perform validation for the calculation and simulation. That is defined in clause 9, which is the on-site measurement for normal mobile base station and also 5G mobile base station. Other than those 3, we also have clause 6 to define the shared sites, as well as clause 10 to define the compulsory signage that we want to put at the base station. So we also have to refer to standards and guidelines in order to develop these technical codes. So the national authorities or organization that is involved that we refer to is MCMC, where MCMC is a regulatory body that is responsible for the regulation of communication and multimedia in Malaysia. So with MCMC, we refer to the mandatory standard that they have developed previously. And then we refer to the ICNIP, which is a commission that is formally recognized by WHO. So they came up with the regulations for non-ionizing radiation. And then we also referred to the IEC for their evaluation method. So IEC explained their standards in terms of performing calculation, simulation, and measurement. And we also referred to ITU documents in terms of the standards for telecommunication, because they have defined specific regulations or SOP for that. This is the main reference that we use. There are 4 documents. The first one is the MCMC mandatory standard that was last updated in 2010. So as been informed, they will update this document soon. So that's why they need information on the technical codes. So this document is very important. All NFP and NSP in Malaysia have to follow this document to ensure compliance. And then in order to achieve compliance, there is another document produced by MCMC, which is the guideline on the MS. And then we also referred to the ICNIP guidelines in terms of exposure limit, because the mandatory standard also cross-ref to the ICNIP documents in order to define the exposure or safe limit for Malaysia. And then we also have the IEC document that shows the evaluation process to calculate the field strength and power density. So inside this document, they also define the SAR, but for the purpose of this technical course, we refer to this document in terms of field strength and power density. Other than those documents, we have a lot of normative reference, like IEC 62232 is basically used for all. First is for calculation, so and then for prediction or simulation, and then inside this document also there is a validation works for measurement. So for all calculation, simulation, and measurement, we refer to this document. And other than that, we have ITU K16, ITU K52, which specifies the calculation of safety zone, especially related to the EIRP for 5G and other mobile telecommunications technology. We also referred to ITU K61 in terms of the numerical techniques suitable for prediction of EMF. And we also referred to Canadian Safety Code and IEC, as well as ITU K61 and K100 for the measurement on site. Why, in terms of the 5G and massive MIMO measurement, most of the contents are taken from IEC 62232. Okay, before I begin with the exposure limit, this is just an introduction about the electromagnetic spectrum. So on the left side is the lower frequency, and on the right side is the higher frequency. So lower frequency has longer wavelength, higher frequency have shorter wavelength. So lower frequency, it has less energy to ionize atoms and molecules. So it means that it is considered as non-ionizing radiation that is not harmful. So although it is non-ionizing, it also has no effects to human, which is limited to heating and thermal effects only. And there's another portion of the spectrum, which is ionizing radiation, like UV, X-ray, and gamma ray. So this portion of spectrum, it is quite harmful to human because it can ionize or break molecular bonds at molecule levels. So we're not talking about that portion of spectrum. For 5G, 3G, 2G, GSM, we are talking about the radio and microwave portion here, which is a non-ionizing radiation. So in order to regulate the non-ionizing radiation, ICNIP has came up with reference level. So when I talk about reference level, that is the safe level of EMF exposure for human. So it is divided into two, occupational and public. So occupational has higher reference level as compared to public because they are trained workers. They work under known limit, and then they also can judge in terms of to take precautions, like they have to wear personal monitors when they enter the sites. So that's why the occupational workers has higher limits. So as you can see here, generally, if we want to measure near field, like the first row is the lower frequency range. So at lower frequency range, IGNIP guidelines treats all exposure within this frequency as near field. Okay, so that's why the parameters that is considered for compliance are electric field and magnetic field strength. However, for the highest frequency range, only the power density is evaluated for compliance, because at higher frequency range, from 2 to 300 gigahertz, it is not possible to use reference level for near field anymore. So we have to seek compliance based on the power density. So this is very important. And then what it means by near field and far field is explained in these slides. Near field is the region located very close to the antenna, and far field is the region located far from the antenna, where the wave already behave like a plane wave, where the radiation pattern does not vary over distance anymore. So as you can see from this slide, if you want to evaluate the EMF exposure at near field, it is within this region, which is quite important for workers. However, for public, we consider to evaluate the EMF based on the far field region. So as you can see here, I want to highlight for lower frequency range, we cannot evaluate based on power density, because like I said before, IGNIP guidelines treat all exposure within this region as near field, because the wavelength or lambda is very high. So every up to a point that it's really hard to measure from far field. So that's why it is near field here. And then for this one, since wavelength is very small, so reference level cannot be used to determine compliance for near field. So we use far field here. So exclusion zone is important because this is safety zone. So based on the reference level or exposure limit stated here, so we can define the safety zone. That means if you have an antenna or base station here, you want to know how safe it is in order to access the area. Can it be very close, or does it have to be very far? So you have to calculate the exclusion zone. So since the exclusion exposure limit for workers and exposure limit for public is different, so that is why the safety zone for occupational workers and for public is also different. So as you can see, this is the top view of the antenna, where antenna is located at the center, and the area very close to the antenna is called exceedance zone. So in that area, the limit is more than the safe limit. So no one can enter without shutting down the base station. So the yellow area is the occupational zone. So based on the previous IGNIP levels, so we can calculate the region where is the occupational zone. And then the white area is the compliance zone, which is suitable for public. So this is to determine compliance. So in order to determine compliance, we have to calculate the exclusion zone. It is based on power density. So S in is the power density based on the EIRP divided by 4 pi d squared, where this is the minimum safe distance from the antenna. So when you rearrange this equation, you get D equals to EIRP divided by this. So you have to make sure that the EIRP or power and gain used in this formula is based on the actual antenna performance to ensure that the distance is calculated accurately. Okay, so this is the typical exclusion zone distance of IMT band base station. Basically, this is calculated from this formula. So let's say we take one example, IMT band N8. So for this frequency, let's say the EIRP or power transmit is 100 watt. So an ICNIP limits for public is 5. The exclusion zone that is calculated for this frequency is 1.26 meters away from the antenna. So that is how we calculate the exclusion zone. The distance are only based on the practical EIRP and antenna data only. That is for the purpose of this technical course. However, for the proper usage of technical course, for the proper calculation of exclusion zone, it must be calculated based on the actual base station specification. So depending on your spec of the base station, the values has to be inserted accordingly. And then before I proceed with simulation, it is important to highlight on the shared sites. There are many shared site categories. Shared site means you have multiple services or system installed in the same infra or different infra but the same location within 60 meters to 100 meter radius. For example, you have tower that consists of many antennas from many systems. You also have water tank or maybe advertising board that have a lot of antennas on it. You also can have rooftop that has a lot of antennas located within it. So for these cases, it's not easy to do calculation of safety zone. So you have to do simulation. However, the things that is highlighted inside this technical course about shared site is about RF owner. So who will be responsible to submit the report to the MCMC in terms of the simulation report and compliance, determining the compliance for their sites. So you can have a look at our TC. So for a single transmitter base station, the safety zone can be calculated by using normal calculation like I showed previously. However, for more than 2 transmitters or antenna, or what we call as complex sites, we have to do simulation, where it can be represented in terms of numerical values of power density or percentage of the exposure limit. So based on ITU TK61, so these are the recommended numerical techniques. For near field, since near field is the area very close to the antenna, we can use FDTD or MOM, but it takes a lot of time. FDTD is based on volume discretization. MOM is based on surface discretization. So FDTD requires a lot of measures as compared to MOM, but FDTD is very good for multi-layer dielectrics. For example, if you want to measure for SAR in human. However, that is not the topic covered in this TC. So we only cover the far field where we simulate the propagation of EMF in complex urban environment. For example, let's say in an urban area, we have a lot of high-rise buildings, rooftops, multiple shop lots, houses, and many more. So there are a lot of reflections, multiple reflections at each building. So it is recommended by ITU to use ray tracing because it is based on geometrical approximation. Okay, based on the simulation, we can indicate exclusion zone. So I've already explained this one. However, from simulation point of view, it is defined in terms of color. So the red zone is the exceedance zone, yellow is the occupational zone, white is the compliance zone. Okay, so vendors have to submit the simulation report to the MCMC. And this is the examples of computed exclusion zone in complex system, like when there's a tower and has a lot of antennas. So this is how the simulation result looks like. This is building and this is oil and gas platform. In order to validate whether the calculation and simulation is correct, so we have to perform the in situ measurement to analyze and confirm the EMF exposure. We have to check whether the base station complies with the permissible exposure limit as stated in the MS and ICNIP guideline, and it can also be performed in near field or far field. And in terms of the device, we have to make sure that the device can perform the selected parameters measurement as well as suitable for the frequency range, and the person who perform the measurement need to wear personal monitor, And we also have to know the number and characteristic of EMF sources in advance. The equipment should be calibrated and the region should be specified, whether near field or far field. So this is the measurement method in general. So we have to make sure that the personnel who do the measurement is qualified, and they have to record the physical condition of the site. In terms of the location, it is important to do the measurement at the worst case situation. For example, the location must be the nearest accessible location facing the main lobe, which is like this measurement setup here. You have to identify the main lobe, and the location of the measurement should be at the location facing the main lobe if possible, because we want to measure the worst case. And then we have to perform the test and verify for compliance. However, for 5G, the situation is more challenging because in establishing the 5G connection, so beam steering or beamforming is used, where synchronization block SSB signal is also sent to all. So the user will determine the strongest match of the signal and reply back to the base station. So that is synchronization signal and not the data signal. So sync SSB signal and data signal can be sent in separate beam or the same beam. So normally SSB and data are sent in different beam. So if we want to take only the electric field strength from the SSB beam, it is like an underestimation of field strength because it does not contain data. So that is why in 5G we have to do extrapolation. And another case is in 5G we don't have a reference signal that is spread over the entire channel bandwidth. The only signal that is always on is SSB. However, in terms of the data is fluctuating. For example, if you look at this carrier, SSB is always on. However, the data is fluctuating because in 5G it is based on packet switching. So we have to take assumptions for that. So the solution is we take the measurement of EMF for all visible SSB in that location. Say we take from one beam and then we extrapolate to full bandwidth, and then we do the summation of all SSB. Okay. And in summary, this is how we do 5G EMF measurement method. We do the 5G signal scan and then identify the reference frequency of the SSB because SSB is the signal that is always on. And then we measure the electric field strength for each visible SSB. We extrapolate over full bandwidth. We do time averaging and then extrapolate to the maximum field based on the fully occupied data channel. However, that is the case for single array producing multi-beam. Okay. However, for 5G, there are two operating mode. The second mode is like multiple array and multiple beam. Just now I was talking about single array producing multiple beam, where it is based on beam indices or beam index. This one, when we have massive MIMO or multiple array that produce multiple beams. So the situation is more complicated and more challenging. So you can refer to our technical codes. Other than that, we have subject matter expert on 5G today, which is Mr. Anwar. So if you want to have you want to ask any questions, you can also forward the questions related to 5G massive MIMO measurement to Mr. Anwar. The last but not least is the signage. In order to indicate the compliance level, which is important for the public, we are proposing to put notice signage, just like the one shown in the slide. So you can see that the base station comply or not to the mandatory standard by looking at the signage. I would like to also acknowledge all the EMF sub-working group members for working really hard in developing these technical codes. So we have a lot of agencies, private companies, universities, and government agencies, ministry, and so on. So thank you very much for your hard work. Okay, thank you very much. That's the end of my presentation. I'll pass the session to the moderator.
All right. Thank you very much, Dr. Nurul Huda, for the very great presentation. I hope that you can stand by for Q&A session at the end of the session. All right. Again, to those that will have any question to ask our experts today, you may leave your question at the chat box, and our expert will answer to those questions during Q&A session. All right. Next, to present on the last draft codes for today, that will present on the 5G security requirements draft technical codes. The presenter is Mr. Muhammad Fairuz Ismail. He is the Vice Chairman, Application Security Sub-Working Group. He also the draft lead for 5G security, and he is currently working at KPMG Management and Risk Consulting Sdn Bhd. How are you, Mr. Muhammad Fairuz? Are you there, Encik Fairuz?
Yes, sorry, my mic mute. Yeah,
Oh, okay,
I'm good.
okay. All right, great. I think I pass to you for your presentation.
Thank you.
All right.
Start without further ado. Okay. Hi everyone. Good morning. Yeah. Today I will present 5G safety requirement in preparation of a 5G technical code for Malaysia. Yeah. So this is an overview of the 5G security requirement technical code. Why we require a 5G security code technical code here? Yeah, because we would like to establish a 5G security guideline in infrastructure requirement. That's the number one. Number two, the objective is to provide all the recommendation and technical performance and requirement to all 5G operator in Malaysia. And we also would like to set up the measurement or effectiveness of security control end-to-end framework and the benchmarking or rating from our security posture. So the scope is we cover end-to-end security architecture, security standard recommendation from ITUT. We compile all the reference from ITUT, 3GPP, and GSMA, and we also provide a security infrastructure guideline and performance requirement for 5G player in Malaysia, or the vendors that are working on 5G services. Okay, this is outline for today agenda.
Sorry,
Yeah, we have about.
Encik Fairuz.
We have yes.
Maybe you could please put your screen on full mode, the presentation.
Okay, sorry.
Yeah. All right, thank you. You may proceed, Encik Fairuz.
Okay. Okay, today agenda we have about 6 agenda here to share with everyone here on the 5G security technical requirement. Okay, let's go to number 1. Okay, 5G security overview. Yeah. Okay, in a nutshell, 5G security cover a flexibility to all the connected devices and systems. These are the first requirement on the 5G security overview. The second one is visibility. Means that the 5G system is required to have visibilities and abilities to monitor real traffic, real network connectivity status. Yeah, and the last one is to provide protection. I mean security protection to all against any attack vectors. Yeah, from any security threat. Yeah, and the important thing here is to protect 5G network access, yeah, which cover user information, mobile call, yeah, radio, all the way out to internet connectivity. Yeah. Okay. So I would like to share about the 5G security guideline and infrastructure requirement. We have about 11 structure: cybersecurity, security architecture, end-to-end communication, security accession markup language, entity authentication assurance framework, common editing protocol, access control markup language. And the important thing here, or the guideline that we cover here, is based on the ISO IEC 27002, which is from ITUT 1051. Yeah. And you also have cover a technical code along with the recommendation from ITUT X .1 to 40. Yeah, this one is to protect from any spam call or country any anti-robocall, right? Yeah, and the last security guideline is abstract syntax notation and cybersecurity information exchange framework. I will explain this one in more detail in the next slide. Yeah. Okay. These are overall requirement for 5G security infrastructure. If you can see from here, our 5G, yeah, all the way in terms of 5G elements, we're talking about the hardware, transmission equipment, new radio, mobile core, NFB, the system, right? Yeah, core network, and also the management of internet connectivity to the service provider. Yeah. Okay, section 3, we're talking about the technical performance and requirement. We have provides a guideline for all the operator, 5G operator, minimum technical performance for 5G. Yeah. So this element is very important to take note for all the 5G player. Yeah. Bandwidth. Yeah. The maximum aggregated system bandwidth, energy efficiency, mobility instruction time, connection density, mobility in terms of speeds, reliability, yeah, and the last one, user plane latency and control plane latency. So in the technical code document, there's all the detail under the 5G minimum technical performance. Okay, this overall 5G minimum technical performance specification. You can see here we have a downlink speed and uplink speed. Yeah, based on user case category, indoor or dense, urban or rural. There is downlink and uplink speed here. Yeah. This thing we talk about the performance specification as well. End-to-end latency. If you can see here, there is end-to-end latency for broadband. For example, broadband access in an area require minimal latency about 10 milliseconds. And the mobility speed is 0 to 100 kilometer per hour. Yeah. So you can see all the details here from the broadband use case category until broadband like services. Yeah. Okay. Let's go to 5G security architecture security domain in detail. Okay. 5G 3GPP security architecture consists of a 3 stratum. Yeah. First one is application stratum. Second one in the middle, yeah, home stratum or service stratum, and the last one transport stratum. This is the 3 layer of stratum in the 3GPP security architecture reference. Yeah. So under this 3GPP security architecture, we have security domains. Yeah. Okay, we have about 6 security domains here to map back to the security architecture. Yeah. So we have network access security, network domain security, user domain security, application domain security, service-based architecture, and visibilities and configuration of the security. Yeah. Okay. Let me brief a bit about the security architecture plane. If you refer back to the previous slide, right, we have a security plane here for management, security plane for user data, and security plane for control signaling on the horizontal. Yeah. On the vertical, you can see here there is an element from 5G security architecture, ME, AN, ASN, and SN. So all these elements, we have a security control under the security architecture planes, which is a security plane, a security plane management for user data and control signaling. So under these three security elements, we provide end-to-end protection for security planes that can cover from the management level access, second is user access, and also control signaling access. It's also designed by two security mechanisms here. As you know, it's running on the NFV, SDN network. So we require a slicing management security mechanism and also slicing management security mechanism for SAS, and also event control for vertical and also horizontal network policy. Let's talk more detail about the 5G security control classes and end-to-end framework. Okay, these are overall of end-to-end security framework. If you remember earlier, I mentioned about the transport, home, and service stratum and application, right, on the vertical. Okay, this element inside the transport is new radio RAN. Under home stratum, we have H network, a core network, which is the mobile core, and it's connected to application stratum, which is internet services or all the application from the mobile operator. Okay, so now we zoom into a horizontal plane just now. So we have a security plane for control plane signaling and security plane for user data. If you can see from here, all the devices, end-to-end devices, all the way to network radio RAN, H network and control network, is sit in between a security plane of control plane signaling and also security plane of user data. So there is a security control under the security plane of control signaling and user data. I will explain further in the next slide. And we also have a security plane for management system for operation. They can have a visibilities end-to-end all the way from end users to the applications services. So how we want to protect our 5G security and architecture framework. So we have, from your left-hand side, we have vulnerabilities. Vulnerabilities may come from internal devices or internal element, or from external. So what we're going to do here is we have to protect end user control and management plane, which is hardware itself or software under the security domain. So from left hand side we have attack vector or threat, security threat. So how we're going to protect from attack vector or security threat? We're going to implement security control classes. Let me talk about security control classes. In the next slide. So 5G security plane and 5G security layer. Okay. In summary, all the security plane will have a 5G security layer. So for example, end user security plane, they will have application security layer, service security layer, and infrastructure security layer to protect end user plane. And each plane will have a 3 security layer. Okay. And this security control classes to protect from any attack vector or security threat. We have access control. We have authentication, non-imputation, data confidentiality, communication security, and data integrity, availability, and privacy. So these 8 control classes is required in this 5G technical code in order for us to protect any attack vector or security threat from external. Okay. In summary, you can see from here. We have from the hand side vulnerabilities. we have vulnerabilities, security control for vulnerability is security layer. Just now we talk about security layer, applications, security layer, service security layer, and infrastructure security layer. That can protect end user plane, control plane, management plane, which is our mobile operator hardware or software. And from right hand side, we have security control classes. Okay. So we also categorize end-to-end security framework, so that we can identify the security threat, what is the security control, each element. For example, under categories end user, okay, we categorize the element by physical, technical, and administration. Okay, for physical, for example, right, security hardware. What is the security control here? So security accreditation scheme SAS for UIC ESIT. Why you try this one? Because you want to protect from device tampering. So we map all the security threat into the security control so that the operators can have a guideline to protect from each element here. Okay. For example, each network, physicals, they need to have secured hardware. And for technical, they have NFV, SDN security. So what is security control? Okay, we put here resource isolation, security isolation, software defined segmentation, encryption, IPsec tunnel. So these are security control in order to protect from any security threat here, list out here, right? Like DDoS, MAC backhaul sniff, MAC server vulnerabilities, slicing, theft. These are examples. So for in terms of administration, we have to secure user access. Security control is user access control. And what's the security threat? We put here improper access control or data information exploration. So I go through all the categories, right? All the way. This is operation, physical, technical, administration, operation. We also have security element and recommendation as well. For 5G security element and security element, we also list out the severity so that we know that what is the priority for mobile operator, to define or to have proper security control in the 5G security network. Okay, the criteria here we evaluate element by type of impact and also scale of impact. Okay, from the categories of network function, for example, core network function. This example of key element, user requirement authentication, roaming, session management function. Okay, and we put here severity is very critical. Means that all the operator, if they want to deploy 5G security, 5G network, they have to take care of this the core network function. So same goes to NFV management and network orchestration, MANO. The severity is very high, which is critical, because of many high important functions such as a core access or core function or lawful interception security cryptography. This might will affect the function necessary to operate 5G. Means that if NFV down, the whole network is down. This that's why we put here is severity is critical. So you need to take care of the NFV. So let's go to the other category, RAN. We put a medium because base station we have redundancy. In 5G we have lots of base station. Medium. Just transport and transmission function we put high, in internet network exchange we put high as well, due to the example of the key element and the discussion here. Okay. We also a part of IGT and also TGP reference. We also put some of example or recommendation from NIST, which is IDT that can cover or can strengthen the 5G security. So identity, protect, detect, respond, recover. This is a NIST guideline for 5G operator to to put in the consideration, yeah, in the planning stage. Yeah. Okay. Just to share a bit before we finalize our technical code. We do have a session with all the 5G operator, for example, Cycom, Maxis, DG. Yeah. So we receive all the feedback from a 5G operator, and we also receive from Cybersecurity Malaysia. Yeah, these are the feedback. This feedback from Maxis, from NAXA, from TM. So the final technical code, we have all the security requirement that has been agreed with all the security with all the operators, 5G operators, and also the regulatory bodies. Yeah, yeah. I would like to thanks to all the members. Yeah, sub-working group. Yeah, including yeah, in JSFB as well. Yeah, in NCMC. Yeah, and all the operators. Yeah, I think that's all. If you have any question, yeah, we just put in the live question, then I will answer. Yeah. So I also have okay. These are all the standard in the appendix that we share later. Yeah. Once the technical code finalized. Yeah. Thank you. Yeah.
Okay, thanks a lot to Mr. Fairuz for the great presentation. All right, currently we have around plus minus 160 currently viewing or participate in this MTSLB public engagement session. All right, I already have some questions with me right now. The first question, I think Mr. Anwar will answer to this question. Okay. All right, the question is coming from Ahmad Nazrin from Penang. So the question is, can you send any white paper regarding 5G EMF measurement or some sample study that been done before globally? I think you got it, Mr. Anwar?
Yes, yes, I got it. The question, yes. Right. Thank you for the question. That's a very good question. So, as what we know, currently there have been two studies related to 5G EMF, specific to 5G EMF that has been done before. The first has been done by Ericsson in Belgium, using the method that we have described based on the technical code, which we refer to the IAC document. The second is from Switzerland Meteorology Department. Both documents are published, and there is also a white paper that summarizes the method that has been used by these studies that we can also share to the participant. Do we have the email, Mr. Shazali, for the participant for us to submit this document?
Yeah, I think we will get Mr. Ahmad Nazrin to submit his email, maybe through the chat box. Mr. Ahmad Nazrin, maybe you can post your email to chat box, or maybe we can share our contact person, and maybe you can email to us lah. Okay, I think.
Do you need me to share the document here as for viewing?
No need, Mr. Anwar. I think.
Okay. Right.
Yeah, we still have a lot of questions.
So the email, and then we will send the document that is requested by the participant.
Yeah. Okay. Okay. That's great, Mr. Anwar. All right. Thanks a lot, Mr. Anwar. Okay. For the next question, this question, I think Dr. Nurul Huda will answer this question. This question comes from Mr. David Lim from U-Mobile. The question quite long. Okay, the question is, my comment is on the EMF radiation safety limits, table 2, page 5 on the TC document. I feel that this table 2 gives the wrong info that occupational workers can accept higher levels of radiation exposure than the public. As shown on table 2, occupational workers' human body seems to be safe in receiving radiation levels of up to 10 watt per meter square at 400 megahertz range. But in the same table, public's human body can only accept lower safety levels. Essentially, both occupational worker body and public body are the same human body and should be having the same safety exposure limit. They cannot be different. So he suggests table 2 probably should define the different environment or location, radiation level allowed for either public or occupational worker present or access. You can answer, Dr. Huda.
Okay, thank you very much for the questions. So as I explained in the presentation, the exposure guideline limits for workers are higher than the ones in public because workers are generally adults who are exposed under known conditions. Okay, so they are trained to be aware of the potential risks, and at the same time they know how to take precautions. For example, in order to enter the site, they must wear the EMF personal monitors to monitor the field strength by themselves. So workers that are not at work will be regarded as a member of the public. So they will follow the public exposure guideline. Only the ones who are at work has to follow the occupational workers guidelines. Okay, regarding the different environment, so I have already explained in terms of the exclusion zone, safety zone. So there are different zones for different categories. So maybe later on they can study on what is the exclusion zone or safety zone of the workers and also for the public. So that's all from me. But if Prof. Tariq has any comments that he wants to add, also you are welcome to add.
Yeah, actually for your information, everyone, together with us today, we also have our experts that will answer to all of your questions. We have with us today Professor Dr. Tariq Abdul Rahman. He is the advisor for National 5G Task Force, and he is the advisor for IFN Working Group. How are you, Prof. Tariq?
Okay, Alhamdulillah, Fazli.
Okay. Okay, we have also together with us Mr. Azlan Muhammad Ghazali. He is the chairman of Application Security Working Group. How are you, Mr. Azlan? Yeah, also we have together with us Mr. Yo Chun Yo. He is the draft lead of IMT 2020 Working Group. I think Prof. Tariq, maybe you want to add something to the question number 2 just now?
Yes, exactly. I think I just want to add on what I think Dr. Huda has mentioned, where you have two types of safety. One is for the workers, and then another one is for the public. For the workers, basically, as mentioned, it is higher because they are known and also they are wearing the protective devices. I mean, they know the radiation, and that can be that's why the level is a bit different. But for the public meaning that the public can be the adults and also can be the children, which means that they don't know what are the radiation surrounding them. Okay, so that's why the level is different to be the protected. So this is what I want to add on. What I think Dr. Huda has already explained on that part. Okay, thank you.
All right, thank you very much, Prof. Tariq. Okay, I think for the next question, this question to Mr. Fairuz. Okay, this question related to the security camera at RAN site, RAN site, as per clause 9.3.2.1. Is this a mandatory requirement for all sites nationwide? You got the question, Mr. Fairuz?
Yeah. Let me take this way. Okay, the guidelines, the technical code guidelines or reference can be considered as mandatory. So recommendation. And later on, once we submit the technical code to SMC as a regulatory body will mandate the requirement, whether we become mandatory to implement nationwide or maybe based on the decision of the physical or environment. So it is basic. Yeah. I think that is my answer. Yeah. Yeah.
All right. Thanks, Mr. Faris, for the answer.
Yeah.
Okay, we have another question. Oh, there's a lot of question. Quite overwhelmed. Okay. I think this question, Mr. Yo Chun Yo can answer this question. Okay, the question is, for the benefit of everyone, would like to clarify on item 5.1 A is referring to the system capability in general from 3GPP or ITU and not operator design criteria, which is dependent in the spectrum bandwidth. You got the question, Mr. Yo?
Yeah, I got the question.
Yeah.
Yeah, I think that is correct because what we actually putting up as the user experience data rate is based on the ITU recommendation, and they are actually the evaluation method is actually reported in the ITU RM2412. We will further actually define the assumption bandwidth that actually being reported over there, so that operator can actually get a better idea on how much actually bandwidth on the test environment and test scenario that actually we come out with this user experience data rate. So it actually depends on the assuming supported bandwidth that require for each test scenario, especially for the dense urban site. Okay. Yeah.
Okay, all right. Thanks, Mr. Yo. I hope the answer will suffice enough. All right. I think for the next question, Mr. Anwar can answer this question. The question come from Mr. Azlan from Tactical Communication Sdn Bhd. Okay, the question is, as we know, the frequency suggested for 5G is 700 MHz and 3.5 GHz. Can you comment on millimeter wave communications in 60 GHz as sub-gigahertz frequency to provide the MBB services such as VR, AR, and ultra high definition video, UHDV? It can support the requirements on the high growth of mobile traffic and reduce bottleneck. But the blockage of the electromagnetic signal and designing integrated circuit are the biggest issue. Any implementation suggestion on millimeter wave frequency for 5G in Malaysia?
Thank you very much for Mr. Azlan for the question. As I present in the slide and also in our technical document on table 3, there is frequencies available to use for 5G, and we based that on the release 15 document. So far, it's true that 700 meg and 3.5 gigahertz are the but these are not limited just to this frequency. These are what we still call the popular frequencies, but below 6 gigahertz or below 10 gigahertz, there are actually a few more frequencies range that is available for 5G usage. For millimeter wave, currently based on 3GPP release 15, the frequency range that we have listed down range from 24 gigahertz up to 40 gigahertz at the moment. And as I mentioned in the slide, that 5G is based on to cater for the different use cases. So you are right, for the AR, VR application, these are the use cases that can utilize 5G technology. Now, the question on 60 gigahertz, there is possibility to run the 5G frequency at this range. However, it is not covered by the global, the 3GPP document yet. So we have to wait to see if it is released, if it is already proposed in the release, which is release 17, which is to be further next year. But so far, officially for the based on for the 3GPP standard 5G, we suggest based on the GPP release 15, which are up to 40 gigahertz only. And this is, I think, still valid for release 15.
All right. Thank you.
Shazli,
Yep.
Shazli, can I add on what? Hello,
Okay. Thank you, Ms. Anwar.
Shazli, can I?
Okay. I think.
Mention.
Yeah. Yeah, Prof. Tariq, you want to add something?
Oh yeah. Okay. I think just to add on what Anwar has mentioned, for the 5G, for 5G, basically they are looking into 3 different bands: lower band, mid band, and higher band. And the lower band and mid band, basically the frequency below 6 gigahertz, including 700, the band, and also 3.5. There we call FR. But we have also another higher band, is in millimeter wave. At the moment, the millimeter wave, you are talking around 26, 28, maybe 38 gigahertz, and so on. Basically, the spectrum is set by the WRC. In WRC, 15 already identify all the IMT frequency band, including 5G below 6 gigahertz. And when you come to WRC 19 recently, is looking for the frequency also in the millimeter wave. They are looking between 24 to 86, but at the moment, they are looking up to what been defined now is what was mentioned, 26, 28 or 38 gigahertz up to 50. But I think future spectrum for 5G or even higher 6G and so on, they may be looking into the millimeter wave band. Maybe can cover up to 60 gig and above that. Okay, so that is the and for millimeter wave, of course, this is basically for the small cell. You mean looking into 200, 300, there should be some will be multi-beam, and one of the things that can be used for there is of FWA or fixed wireless access and other use cases examples. So okay, that's all. Really. Thanks.
Okay, thanks, Prof. Tariq, for the answer. I think for the next question, I think the Prof. Tariq can answer this question because you mentioned already about the safety suit just now. So the question comes from Mr. Abdul Hadi from Time. The question is, should occupational workers be wearing special safety suits in the future? I think Prof. Tariq can answer the question.
Yeah. I think is that there's a requirement for the workers to wear the safety, because they know that they are working into the area very close to the base station, and there will be radiation will be higher, and they have to be a protective measure because it's a need to protect them to ensure that they are below the what been specified by the ICNIC under that case. But I think the other case for the public, I think because they don't know, the public can be adult and also children, but normally workers are adults. For the public, of course, we have a law as I mentioned earlier. So they have to wear a safety. That's why Dr. Huda also mentioned that there has to be some of the indicator showing the radiation level because they are very close to the station. So,
All right. Thanks, Prof, for the answer. So of course, occupational workers need to wearing a safety suit lah. All right. Next question also come from this one from Mr. David Lim from U Mobile. I think Dr. Nurul Huda will answer this question. The question is, table 2 shows worker acceptable EMF level. No statement of PPE or even N9 grade. Dr. Huda, maybe you can answer the question.
Thank you for the question. I think this question also is related to the previous questions about the safety suit. In my opinion, normally people wear PPE for ionizing radiation because they want to prevent from contamination of radioactive materials and so on. But for non-ionizing radiation, actually although you can wear it, but there's no actually global regulations that specify the use of PPE for workers because the known effect is heating and thermals. So as a worker, they can generally think that if they are not comfortable with the heating effects, so they can move away from getting closer to the sites and so on. So it is also as specified in the WHO or ICNIP recommendations for that. Okay, thank you.
All right, I think the questions that answer very good. Hope it answered the question. Okay, for the next question, come from Khairayu Badron. So the question is, may I know if 5G NR or 5G Neo radio have been implemented? I think Mr. Yo can answer this question.
Yeah. If you're talking about globally, of course, it's already intended. Even in Malaysia, we already have the trial through the 5G demonstration project. One of the key site area that we already deploy is in the Langkawi there. It's actually a full 5G and our technology over there. That's all from my side.
Okay, thank you very much. So it's already here in Malaysia. All right, next question come from Mr. Shahrul Abdul Rahim. I think Prof. Tariq may want to answer this question. The question is, any advice to end user on health safety of 5G EMF? Prof. Tariq, maybe you want to answer this question?
Okay. Yes. I think this is regarding the radiation. And when we say the radiation, many people report radiation can cause adverse effect and so on. But we have to understand about the radiation. Radiation has two parts. One is the ionizing and one is non-ionizing. And you can see that the frequency radio is categorized under non-ionizing. As we see that what we're looking at now up to 300 gigahertz, which is basically non-ionizing. Basically, if you look into theoretically, it doesn't have enough energy to cause the ionization to happen, where it can cause light and so on. So the only thing that will happen is the heating. It's similar to what we use in the microwave. When you put the food in your microwave at Wi-Fi same frequency as Wi-Fi 2.4, but the power is very high. It heat up and increase, but it don't have enough energy to cause the ionizing to happen. But if you can see that, I made a comparison here with the radio frequency that you have, including 5G, which is even the lower part of the radio frequency, around worst case 26, 28, 38, and so on, compared to 300 gigahertz. Comparing with the light frequency, the sunlight. Sunlight is the energy of the sunlight is 1,000 times more than the energy come from the radio frequency. But even it is safe because it's categorized for non-ionized. That's why we can feel heat. Because this the only issue that will happen here is the heating. I mean the raise in the temperature. But when looking into the non-ionizing side, that is we have to consider like X-ray, gamma ray, even ultraviolet ray or infrared and so on. So those are the things that. So what we should understand that when looking to 5G, basically we are thinking that we can make an analogy to compare it with the sunlight. Sunlight is 1,000 times more energy than radio frequency, and even it's still safe. But if you're the more dangerous one is the non-ionizing side. I think we don't have to worry, and that's why ICNIP, ICNIP is a non-ionizing, set a certain minimum to prevent the adverse effect. Even that, if you see most of the done measured in the radio frequency is only 2% of what the minimum ICNIP have set. For example, you see in the tables, in the 2 gigahertz frequency, for example, in the ICNIP, it is about say 40 milliwatt per meter square. And what happening most surrounding when you did a measurement to see is only 2% of that. It's still safe. So that is a thing that, so I don't think we have to worry about that. Okay, that's all. Thank you.
All right, thanks, Prof. Tariq. Okay, we have another question also regarding the occupational worker right now. I think Dr. Huda can take up this question. Also come from Mr. David Lim from U-Mobile. There is a danger of occupational worker wearing PPE when they are working on rooftop or tower microwave sites. The public will freak out when they see this happening and object to any radio sites near their home. Maybe you want.
Okay. All right. Thank you for the question. Okay. It's the same thing about PPE. So that's why I think in global scale, there's no international regulation that specify the usage of PPE. We cannot find any documents that make PPE compulsory for non-ionizing radiation. So it's up to the workers, they want to wear it or not. And even in our mandatory standards, there's no such things as making the PPE compulsory for workers. Since they are wearing personal monitor, is already enough. And then another thing, they don't have the public. The public need no need to worry because when the mandatory standard is in place, when it is after it's revised soon, all NFP and NSP has to comply to the mandatory standard to ensure that the radiation levels from their base station does not exceed with the exposure limit. So this is why we need to educate the public to make sure they know that the base station that is installed in their area complies with the limit. So PPE or not, generally we know that for non-ionizing radiation, it only produces heating or thermal effects, just like what Prof. Tariq has said previously. So the rule of thumb is if the worker does not feel comfortable with the heating effect, so he can just move away from the site and so on. So this is the advice from the IGNIT and WHO. Okay, thank you.
Okay, thank you, Dr. Huda. I hope that answer will clarify the question just now. Okay, we have question for Mr. Fairuz that come from Mr. Hasnor Hafiz Hussein. The question is, in terms of robocall and the issue regarding spam calls, how do you see as our government and MCMC or MTSFB to combat this global issue as we are heading towards 5G and IR 4.0? Mr. Fairuz, yeah.
Okay. Yep. Let me answer this question again. Okay, for Spectrum or Robocom, we put in the guidelines and the code the mission is how to mitigate the Robocom or Spectrum. We propose adoption of a stir injection framework. We review and study the mitigation plan made by FCC, Federal Communication Commission, US Regulatory Body, and also the effectiveness of strategy made by European Communication Body as well, and other Asian member countries, in order for us to adapt stir injection framework and adapt in a 5G deployment. That is our proposed solution for protocol and spam call.
Okay.
Okay. That answer the question.
Thanks, Mr. Fairuz. I think there's another one question for you, Mr. Fairuz. That coming from Mr. Amir Akram Abdul Rahman. So the question is, what is the difference in the 5G security architecture when moving from 4G to 5G? You got the answer? You got the question, Mr. Fairuz?
Okay. The different 5G security architecture when moving from 4G to 5G, we adapt SBA, service-based architecture, in the 5G architecture. In the 4G, we don't have a SBA domain. SBA mainly involve various services that especially the NFV. That's the difference. So when it comes to 5G architecture, there's NFV. So we play in the access network, 3GPP and fast network better more that there's no difference that. Yeah, yeah. Yes, we can apply that. That answer the question.
Okay, Mr. Virus, I think yeah, we have another question for you, Mr. Virus. Okay, from Bob Ng from Road and Sword. The question
Okay.
is, will the security technical code cater for low latency applications like autonomous vehicles
Okay.
and VR? How do we ensure the security layer does not introduce too much latency?
In general, yes, we foresee that there is authority, yeah, in the 5G we can implement security. Uh, yeah, but in the system design itself, yeah, in addition of security, performance threshold need to be considered. So we need to build a grid for those 5G security layer and also education. In the 2020 code, the latency set by them is less than 1 millisecond worth of second. That's the benchmark. So we have to ensure that so that we can compromise any security threat. Yeah, when we implement 5G, uh, 5G uh, in case in for vehicle for autonomous vehicle and VR. Yeah, we need to consider.
Okay, thanks, Mr. Fairuz.
Thank you.
Okay, I think for the next question, Mr. Anwar can answer this question. The question from Mr. Zahid Hamidi from CRES. So the question is, will fiber deployment patterns change when 5G is deployed? Mr. Anwar or Mr. Cho answer this question? Mr. Yo, sorry.
Hello?
Sorry,
Yeah, hello. Yeah,
Mr. Yo, thank you.
Yeah. Thanks for because regarding the deployment patterns, I'm not too sure the context of deployment pattern that you mentioned, but the bandwidth requirements of course will be changed because as you see that the main three pillars that we need to support on the use cases is like ultra reliable low latency. It means that almost all these kind of things can be actually achieved through the fiber deployment that require, especially in how you manage your network elements. If your core network need to be some of the portion of the network need to be closed, need to be far away. If you are deploying cloud rank architecture that far away from the radio site network, then the bandwidth requirement will be very high. And then also in the case that if you have a radio card splitting means that your CUDU, central unit and data unit means that something else on the physical side means that the number of bits that being transmitted will be very high. So you require a fiber. So it's actually 5G is actually a very good opportunity for fiber deployment to be enhanced. Okay, thanks.
Okay, thanks. Thanks, Mr. Yo. I think we
Suddenly,
have.
can I add?
Yeah. Please, Prof.
Suddenly, yes. Yeah, can I related to that? This is one of the thing application for 5G FWA, fixed wireless access. As you see now, we have this all the fiber connected to the home. But by having 5G, which can support the throughput data rate similar or close to the fiber, it can just like the air fiber. So instead of having the fiber to every home at one point, you can have point to multi-point or fixed wireless access to replace the fiber to home into within the 5G signals, which is known as fixed wireless. So this is what we always refer to as air fiber or wireless fiber. Thank you.
Yeah, hello. Yeah, Prof.
Ya, ya.
Yeah, I think Prof done
Tadi
already.
dengar. Ya.
Yeah, I hear it actually.
Okay, okay. Pardon?
Okay, Prof.
Yeah. Yes.
Maybe you
Sorry.
yeah, you may
Prof just now
answer.
mentioned mainly is on the fixed wireless access, means that you actually can use
Yeah,
the
that's right.
5G as an alternative to replace the fiber for the last mile access, especially when going to the home actually. So there's one of the option that actually allow us to actually connected to more, especially on the rural and suburban area, which fiber is very hard to penetrate. This is one of the very good option or good alternative that 5G can offer, which is called the fixed wireless access.
Yeah, yeah.
Okay, thanks, Mr. Yo. I think we have two last question. This question maybe Prof. Tariq will answer this question because related to 5G National Task Force that come from Ahmad Taufik Nick Nur Azlan from TNB. The question is how the performance of 5G that already installed in Langkawi. It is meet requirement of 5G. How it goes?
Okay.
Prof, you may answer.
All right, Shazali, thanks. I think in the Langkawi, we can see that there are demonstration or the use cases, example, where 5G can do. There are verticals that have been shown, including what you call the agricultures and so on. And I give you example that what been done because of the low latency, because there is a what you call the connection for the remote consultation, for example, where we remote it can support 4K, 8K, and also with the low latency, the doctor in the hospital in Langkawi, for example, can consult the doctor in Olostar in the real time and can show, for example, some sort of the thing that to give advice and so on. And there are few, I think these are the few use cases, example that we done in the Langkawi and where it can demonstrate the capability of the 5G. So I think here more looking to the verticals, not you're talking about beside the enhanced mobile broadband, you're looking into the low latency where you can have remote surgery, remote consultation, and smart manufacturing and so on. And also can support a massive machine type communication, for example, in terms of sensors, IoT, and all those things.
Okay, thanks, Prof. Actually, I have a question myself. Actually, Prof, to you.
Oh yeah.
Uh,
Okay.
as of my knowledge, I know that Korea already commercialized their 5G. So, in your opinion, what is the key enabler that Korea made so that they can launch or commercialize 5G in the first place?
Okay. I think one more thing, as you know, 5G require fiber. Every tower of the 5G require you need at least to have the fiber to be connected. And one of the things, the successful implementation of 5G in Korea, I think, because there are fiber everywhere, so easily for them to implement to put the base station of the 5G throughout the country. And second thing is basically one of the things that use cases, in Korea, they are like gaming and all these things. And since it can support very low latency, for example, you have the VR. When you have the VR with 4G, for example, you use a VR, I mean, there will be a delay. Delay means when you wear the VR, you can have a head. But with 5G, with 1 millisecond latency, that is just like a real time. And these are just an example. And I think what I understand that the introduction of before they were when they introduced 4G within the same period and compared to when the 5G be introduced, I mean the takeout of 5G is much faster than what experienced from the 4G sites. Okay, Sadri.
All right. Thank you very much, Prof. Very satisfied with the answer. All right. I think because we still receive question, I think this will be the two last question lah. Hopefully, that come from Mr. Nazri from Rida Associate Sdn Bhd. So Dr. Huda, maybe you can take up this question. How did the MTSFB or MCMC or any respective authority supporting telco operator in answering any public arguments, especially on radiation for BTS sites? Because normally public believes rumors rather than evidence or testimony. Quite an interesting question.
Okay, thank you very much for the questions. Okay, I believe one thing is to do awareness program. MCMC together with MTSFB and in collaboration with the specific working group, they have already done several awareness program, and I believe the public engagement session that we have today is also part of the awareness program to make the public aware on the 5G requirements and compliance. So this is one of the things that has been planned to ensure that the public does not just refer to rumors only. So we want to educate the public in terms of the technical of the 5G. And then another thing is in mandatory standard, MCMC has already put the signage as one of the regulations. So in the technical codes, we also propose for the signage to be put in the base station to say that this base station complies with the exposure limit as stated in ICNIP or WHO regulation and so on. So this is one of the things that the public has to know. Whenever you see the base station with the signage that say the base station complies with the safety limit, so they have to agree that the safety limit in terms of the EMF exposure has not been exceeded for that purpose. And then another thing, that's why we have many validation methods: calculation, simulation, and measurement. So telcos has to submit the reports, the simulation reports, and whenever there's a complaints received by from the public, the MCMC can request for validation in terms of measurement. So that's one of the things that MCMC and MTSFB can do to support the telcos. They can verify whether the signals or EMF exposure for that site meets the safety limit or not. Okay, those are the three things. Okay, thank you.
Okay, thank you, Dr. Huda. I think for the last question, Mr. Anwar would like to take up this question from Mr. Muhammad Faisal. Mr. Muhammad Faisal, sorry. So the question is, what is the ratio of 4G and 5G base station number if we're looking for autonomous vehicle in Malaysia?
I think I would like to refer this to Mr. Yo from TMRD. Thank you.
Yeah, Mr. Yo to answer this question.
Okay. So basically, I don't have that figure of the ratio, but I think this is when you're talking about the autonomous vehicle, I think it falls into the category of ultra-reliable low latency. So means that the base station have to be somewhere to make sure that the latency could be secure. It could be actually need to be in the dense kind of deployment. So of course, the ratio of the 5G base station will be higher compared to the 4G. Because 4G ultimately there are no use cases that supporting this kind of ultra reliable and low latency. As for your information, the user plane latency for the URLCC actually have to be targeted in the 1 millisecond. And this also have to take into consideration on the number of connections that can be set up. So I would say that autonomous vehicle is something else, could be something deployment more on the kind of like control environment and not something else that you will be expect from the heartbeat that you can actually access it as a LTE kind of mobile phone kind of use cases on that is a normal like download, upload, but it more on the control environment, and then the base station have to be actually securing and guarantee the latency that required for that. So this is my answer. So for the ratio of the 5G base station, I think cannot do an apple comparison, but it will be something else that in a dense deployment kind of scenario and in a controlled environment, including you need some kind of MEC support for that. Okay.
All right. Thanks, Mr. Yo, for the answer. With that answer, I think we close the Q&A session. Really thank you to those who asked questions, and thanks also to all the presenter and our experts for answering the questions. I would like to inform to all of you also that together with us, there are our collaborators from Japan. That is 5GMF, from Korea, 5G Forum, and also from India, our collaborator from India, TSDSI. All right, I also want to share with you on the feedback that we received via our Facebook comment. Thanks, Prof. and the presenter for the clear explanation on radiation of 5G radio, terbaik and whatnot. Okay, thanks all. Thanks again to presenter. Thanks to Prof. Tariq. Thanks to Mr. Yo, Mr. Azlan, Dr. Nurul Huda, Mr. Anwar, and Mr. Fairuz for your time.
Thank you.
All right. Like I mentioned at the early of this session, we really love to hear your feedback regarding our event today. So for those who participate in this live event using your laptop, all right, you may use your smartphone to scan the QR code for online feedback form. Maybe you want to ask a question, maybe you can pose it there as well. And for those participate this live event using your phone, you may go to the comment box, look at the pinned comment, and click on the link for the online feedback form. As I mentioned just now, your feedback are really appreciated for improvement for our future live event. All right, I would like to thanks again to all of you that joined our event today. Again, I would like to stress that the public comment for this draft technical codes still ongoing until 18th of June 2020. All right, you may go to our website, just type MTSFB, and you message for the public comment form at the website if you have any comment and feedback. Also for the presentation slide, we will put it on our website. Feel free to view it there, okay? And another information, we still have another 2 draft technical codes on 5G that cover on base station and the user equipment. And the public engagement session will be announced soon. So stay tuned for the info at our website and our social media. And last, we really hope that these 3 draft technical codes can be registered by MCMC, and hopefully the technical codes will become the harmonizer that comprising of all the 5G specifications mutually agreed by the industry players. Hope we will meet again in the future events, and Assalamualaikum warahmatullahi wabarakatuh.